Yes, student. Next one is buffer solution. Okay, it is solution. It is solution which resist the change, okay, in pH, even if small amount, even if small amount of acid, okay, that is which can produce what, H cation or base, that is what, which can produce OH anion is added. Now, how it is possible? A particular solution should have a particular pH value. If we add acid from external source, then it will produce H cation. So, being the H cation is produced, the pH of previous solution must be changed. Or if we add base from the foreign source, then it will release OH anion. Thus, it can also change the pH of the previous solution. But the buffer solution, okay, shows such a nature that even if we add a small amount of H cation or OH anion, that is acid or base, from the foreign source, whenever the pH of buffer solution remains constant. That is what? Same. That is what? No change in the pH value. Now, how it is possible? It is possible because the buffer solution is a specific solution. It is not a common solution, but it is a specific solution. Actually, student, buffer solution are of three types. Buffer solution are of three types. Like the first one is called acidic buffer. Acidic buffer. Okay, this is solution of acetic acid CH3 COOH and its strong electrolyte, that is what, CH3COONA. This is what, acetate, CH3COONA. Now, how the buffer action takes place? I told you earlier that even if we add acid and base, then there should be no change in its pH. So how it is possible? It is possible because, student, you know that acetic acid is a weaker acid. So its aqueous solution produces what? Acetate ion, plus it produces what? H cation. But if we add a small amount of strong electrolyte CH3COONA, now it is what? Strong electrolyte. So it will ionize completely and will form larger amount of acetate ion and Na cation. Now the common ion effect will take place. That is, according to Le Chatelier's principle, the increased quantity of acetate ion in the product side will suppress the reaction towards, that is, backward direction. Therefore, what? The H concentration will already what? Gets decreases. So if we add what? H cation from outer source, okay, then this H cation will react with what? Acetate ion. Will react with acetate ion because its quantity is more. Okay, so there will be no change. So there will be no change in pH. Isn't it? Similarly, student, we have one more type of buffer solution. This is what buffer called what? Basic buffer. What is this basic buffer? If we add NH4OH, okay, with what? NH4Cl. Now, NH4OH is a weak base, so it will ionize to produce what? NH4 cation plus what? OH anion. But if we add and make the buffer by adding NH4Cl, now NH4Cl is a strong acid, strong electrolyte, so it will produce NH4 cation plus will produce Cl anion. That means what? That means in the product side, the concentration of NH4 cation is more. In the product side concentration of NH4 cation is more. Hence, on adding what? OH anion, that is what beta? Base. Okay, will combine with what? Excess NH4 cation. Okay, hence there will be no change in the pH. Hence, no pH change. Okay, student, one more type of buffer is called, this is called neutral buffer. Neutral buffer is only one compound, but this compound consists what? CH3COO NH4, that is ammonium acetate. Now, the ammonium acetate will ionize to form acetate ion and NH4 cation. So, if we add H cation or OH anion from the outer source, then this will combine with acetate ion, that is H cation, and OH anion will combine with NH4 cation. Thus, there will be no change in the pH value. Student, the buffer solution has great importance in our practical life. Like, student, we know that our blood, okay, the pH of blood, it is exactly what? 7.38, or you can say what? 4. Okay, but we are getting different type of food material in our daily diet, and this food material may be acidic or basic in nature. If it will add with the blood, then it can increase or decrease the pH of the blood. And if the pH of the blood will change, then it can cause many difficulties, many disorder. Getting? But due to the buffer nature of our blood, okay, its pH remains maintained. That is, there is no change in the pH and we remain what? Healthy. So these are the application of buffer solution. Student, in fact, this chapter is completed. Rest of the parts, salt hydrolysis, etc., these are deleted in this session. Okay, therefore now in the next period we will start new chapter.